Hi lads, in this video I'm going to go through this question here in orthographic projection. It tells us figure 2.13 shows a pictorial view of a solid. Part 1, draw front elevation looking in the direction of arrow A here. Part 2, draw an end elevation looking in the direction of arrow B here. And then part 3, draw a plan from the front elevation. The first thing I'm going to do is actually draw boxes to fit all of my views. So from the direction of the arrows I can see that the elevation is going to be positioned on the left hand side, and I can see that the total height is going to be 70. I'll take the line up here, measure up 70 mil, and take that across the page. Look at the heights never change. The width of the elevation is going to be a total of 70 plus 50, which gives me 120. So let's take 120 there. And that gives me my box for my elevation, and if I extend my lines down to plan, they give me my width for my plan. So just put a gap in between them there then as well, and then the actual thickness is going to be a total of 70. I take that 70 across there, and take my angles up at 45 degrees then to give me my end view. There's my three boxes to fit in my elevation, plan and end view. So starting off with the elevation, I can come in 10 mil here, and I'm told the width of the triangle at the bottom is going to be 50. And I'm told as well that the angles on the sides are going to be 60 degrees where they meet. And by doing this then I'll be able to get the height of my triangle as well as a result. There we have that there. Another bit of information I have is that this point here is up 10 mil, and that's going to go on an angle. So let's take the sheet back in here again. You can see I don't know the height of this point here, so I won't be able to draw this line yet. I'll need an extra view to actually find that, so maybe my plan or in my end view. So all I have is the height up to this point here, which is 55. So take that 55 there, and that can go across. I'm told then that the radius of the quarter circle I have is going to be 50. And that can be taken down then there, and across to my edge, and then that can be taken down as well. I'm just drawing in heavy now what I can actually see so far with all the information given. So that's all the information I have so far. I can't draw the curve either on the front here, as I need my plan and end view as well to see where my points stop on it all the way around. So after that then, I can start focusing on my end view then. So I can just take some of my heights across. So there are the heights I have so far, and also the 10 mil here. I can see from looking at the side that this side here is going to be heavy all the way to there. I'm then going to have my radius 50 here, and then that's going to go down as far as hitting my slope, which I can now draw in. So I'll be connecting this point here to this point here. I'll just draw that in lightly for now. And I can also take my line down as well here. After I'm going to stop there, as I won't have as much information unless I draw some of my plan now. So at the moment I have loads of information here, and now I need my plan view to get more of the points I need to solve the rest of the question, such as the height of the line here is going to connect. So in my plan, what I have is I have my surface going all the way over here to my edge there. I'm told it goes out 20 mil here. And at that point there, connects to this point here. I'll just draw them lightly for now. I'll then take down my triangular surface down. So this edge here is going to run along there. This one is going to stop it here. And for my center one, I don't know where it's going to stop yet. I have to use my NV then again to solve that part. I can then take my radius 50. And swing that around as well. Give me my quarter circle in plan there. And if I take this over and across, they'll line up then as well. See there, they line up. And then what I can start to do is I can start to take the points and I look in this way at my triangular surface. So for example, where this point on the ground hits. So if I take this across, and over 45 degrees, I get my point there on the ground. And then also, when I take it up, I'll be able to get the point where it hits on the actual surface as well. So you can see there, it's going to hit along this surface here. So I need to find out exactly where that stops. So what I need to do is follow it around excuse me, in my plan up to my elevation. So I need to take this line across here, goes over 45 degrees, and that goes straight up there. And what I'm now drawing basically is that I'll show you in the book. In end view, I've drawn that surface there, and that now gives me the height, which is here. I can now take that across. And connect these two lines together as a result. Now that I have this point on the ground here, I can now find this point here in my end view as well by taking that across. So where the two connect up. And that goes all the way across to my sloped surface. So it's supposed to stop exactly where it hits it. So this line here, remember, is this line here. What I can then do is connect those two together. So the point on the ground here connects there. And that goes back there. And the one on the other side, if we look in there, we can't actually see it, so it's going to be hidden detail. So we take this across, and it hits the line at that point there. And where it hits it on the ground is at this point here. Take that across, up at 45 degrees, might connect these two together, and they're going to be hidden detail. And the rest of the line is going to be hidden as well as a result, because it's being blocked by that surface there. That across there. And draw this in heavy, because when you're looking at the side we can see all that surface there, and that will go across heavy all the way into there. And where that points hit that surface, we can take that down and into our plan to give it our point where it hits the line then along the centre here. So we take that distance down there, over 45, across there, giving me that point there. This point goes down to it here, and this point then goes down to there. So you can see where it clearly hits it then as a result. And that gets our surface in there then. Next thing we need to do is just draw our surface down here. Hidden detail obviously behind the edge, it's being blocked. And the last thing we need to do is draw our points on our curve here. Just get our 30/60s to divide it up. And just label it 0, 1, 2, 3. We follow 3 up there, so 3 goes all up to there, goes straight up, hits that point there, that goes across there, and that gives me point 3. Point 2, we take point 2 up, and where the stop goes around to the edge there, up to 45 degrees, up to their line at that point there. So we're hitting our slope line. That gives me point 2 here. Same again with point 1. Point 1 goes across, over and up. Gives me that point there. And then point 1 taken up. Just follow it around again. Gives me point 1 there. And then point 0 is obviously on that line there, up, over and across. And then we draw in a nice neat freehand curve then. And that finishes off the question then. So making sure as well to label our views. So we have our elevation, plan, and our end view. So hopefully that video helps anybody who may have been stuck on that question there.